Question says a student measured the diameter of a small steel ball using a screw gauge of least count 0.001 centimeter. The main scale reading is 5 millimeter and the zero of the circular scale division coincides with the 25 divisions reference level. If the screw gauge has a zero error of 0.004 centimeter, the correct diameter of the ball is. Now for the solution, the diameter of the ball is given by D equals MSR plus CSR, that is the coinciding scale reading, into the least count minus the zero error. So substituting the values for MSR and CSR, it gives us 0.5 centimeter plus 25 into 0.001 minus of minus 0.004. Simplifying this, we are going to get the answer as 0.529 centimeter, which is the option C. A physical quantity of the dimensions of length can be formed out of C, G and E square divided by 4 pi epsilon naught is. The C is given as the velocity of light, G is the gravitational constant and E is the charge of electron. The dimensions can be equated as L equals C power x, G power y and E square divided by 4 pi epsilon naught to the power of z. Substituting the values of C in terms of dimensions as L t power minus 1, G as m power minus 1, L power 3 and t power minus 2 and E square divided by 4 pi epsilon naught can be written as m into L power 3 and t power minus 2. Substituting the dimensions for L, G and E square divided by 4 pi epsilon naught, we are going to get an equation as L equals Lt power minus 1 whole to the power of x, m power minus 1, L power 3, t power minus 2 whole to the power of y, and m, L power 3, t power minus 2 to the power of z. Equating the powers on the both sides, we are going to get equations as x plus 3y plus 3z equals 1 and minus y plus z equals 0, which implies y equals z, and the third equation can be framed as minus x minus 2y minus 2z equals 0. Now substituting the equation 2 in this equation, we are going to get the value as minus x minus 4y equals 0 as y is equal to z. Simplifying further, we are going to get y equals z equals to 1 by 2 and x equals minus 2. Hence, the final answer will be L equals C power minus 2. G and E square divided by 4 pi epsilon naught can be taken in a bracket and whole can be raised to the power of 1 by 2. So the final answer will be the option D. If the dimensions of a critical velocity Vc of a liquid flowing through a tube are expressed as eta power x, rho power y and r power z, where eta, rho and r are the coefficient of viscosity of liquid, density of liquid and radius of the tube respectively, then the values of x, y and z are given by. For the solution, the dimensions can be equated as Vc equals eta power x, rho power y, r power z. We can now substitute the dimensions for the velocity, the viscosity, the density and the radius. Since the bases are to be same, we can equate the powers as x plus y equals 0, which can be labeled as equation 1, minus x minus 3y plus z equals 1, which gives us equation number 2, and the third equation directly gives the value for x as x equals 1. Substituting and simplifying the equations, we are going to get the values of y and z as y will be equal to minus 1 and z will be also equal to minus 1. So the final answer will be option D. If energy E, velocity v and time t are chosen as the fundamental quantities, the dimensional formula for the surface tension will be. Using the dimensions, we can equate S as e power x, v power y and t power z. Now we also have the dimensional formula for surface tension as ml t minus 2 divided by L. We also have the dimensional formulas for E as ml power 2 t power minus 2, velocity as L t power minus 1, and the time as t. Substituting the dimensions in the equation of surface tension, since the bases are to be same, we can equate the powers and we are going to get three equations as x equals 1, second equation as 2x plus y equals 0, which gives the value for y as minus 2, and similarly minus 2x minus y plus z gives us minus 2, which implies the z value will be equal to minus 2. Hence the dimensions of the surface tension are e into v power minus 2 and t power minus 2. So the correct answer will be option B. If F is the force, V is the velocity, and T is the time are taken as the fundamental units, then the dimensions of mass are. The solution is direct. Force can be equated as mass into acceleration. The mass can be written as force divided by acceleration. This can also be written as force divided by velocity divided by time, which gives us F into V power minus 1 into T. So the correct answer is option D.